Hello everyone, this is David Hildreth with Vega, and today we're going to talk about using radar in plastic and fiberglass chemical tank applications. I have helped customers solve level and pressure related problems for years. Our new 80 gigahertz radar, though, is a surprisingly simple solution to a lot of different challenges customers face with chemical tanks. Plastic and fiberglass tanks are found in virtually every industry. This is especially true, though, in the water, wastewater, and food and beverage industries. So let's walk through some of the key challenges we typically encounter in the field. One of the first big challenges is simply being able to make a level measurement in the first place. Maybe there is no process connection available, but the customer is using IBC totes or plastic drums that are constantly being replaced. IBC totes also add another challenge. Most of the time the customer doesn't actually own the tote, and cutting a hole in the top to insert a sensor is impossible. In these scenarios, the customer is often forced to record level manually by sending operators out to look at each tank and determine the actual level. How many times have you seen someone use a Sharpie on the side of an IBC tote? Sometimes they forget, sometimes they don't record the measurement properly, sometimes they run out of product. Manual measurements are slow, they are full of potential errors, and they don't allow the customer the ability to optimize the process. Sharpies just don't do a good job of sending a signal back to the SCADA system. The two Vega WLS61 radar units measuring the level in the plastic drums in this next example are just two of over 40 radars installed at a major food and beverage facility to ensure an adequate supply of CIP solution at different locations around the plant. The drums are constantly being changed out, but the customer always knows how much solution is available and is being used in each part of their manufacturing process. Radar signals penetrate non-conductive products like plastic and fiberglass. The radar signal essentially ignores the vessel structure and gets a reflection off the material inside the tank to determine the level. This allows us to mount the radar above the tank to easily measure level without the need for a process connection or to penetrate the vessel in order to take a measurement, like in the case of the tote or plastic drum. We can even measure through double-walled plastic and fiberglass tanks. The next major challenge is getting a reliable level measurement. Some of the chemicals in these tanks are just simply nasty. A lot of the times they are put in plastic tanks because of how aggressive the chemicals are. Take ferric, for instance. Most ferric tanks out there are so stained you can't even see through the tank wall to get a visual level indication. And the ultrasonic sensor that you typically see in these applications quickly becomes so coated that readings are intermittent at best or they simply don't work. Because the customer in this example wasn't sure of their exact level, they always had to send an operator down to the basement when the chemical supplier was refilling the tank in order to watch and make sure they didn't overflow. They could also only fill the tank about 75% full because of the blanking distance associated with the ultrasonic unit. Now it is a one-man job to fill the tank. No extra operator is involved, and a remote display provides a safe, effective way for the driver to fill the tanks. Use a controller to easily add relays for visual and audible alarms. They can also fill the tanks completely, which saves money on the total cost of the chemicals. This can have an even greater cost impact if the site is a long way from the chemical supplier. Here is another example where the ultrasonic blanking distance only allowed the customer to use about 60% of a day tank. Now they can use 100% of the tank and get an accurate and reliable measurement. Another challenge is where the tanks are located. Are they indoors or outside? When we mount a radar above the tank, we need to ensure that the tank is located inside so that weather such as rain, snow, or moisture on top of the tank doesn't reflect the signal and cause a measurement error. We really aren't concerned about dust or dirt accumulation on top of the vessel, because this typically won't interfere with the radar signal. We can use radar outside without a process connection, but we have special installation requirements that must be followed to eliminate interference with the signal. Reach out to me or your local Vega representative and we can walk you through this process. We talked in my last video about the problems people experience with ultrasonic measurement. There are simply a lot of issues with ultrasonics that you don't have to worry about with radar. Weight scale is another method people sometimes use to try to determine how much product is in a tank. Sometimes they work great. Sometimes they drift or get built up and become inaccurate and unstable. They are expensive though, and just like ultrasonics, they require annual calibrations to keep them working properly. That's extra money you don't have to spend when using radar, since radar never requires calibration. We've talked about a few of the key challenges, but I also want to touch on some hidden impacts. At a time when everyone is looking carefully at their budget dollars, Vega's new 80 GHz radar products provide a very cost-effective solution. We allow customers to easily automate and optimize applications that were difficult in the past. Our new radars are also less expensive than either ultrasonics or wayscales. There are virtually no ongoing maintenance requirements, no annual calibration charges. Budget dollars aren't tied up in the need to keep extra inventory on hand in case someone made a mistake or simply forgot to check the level of a tank. And this can be especially huge if we're talking about a $20,000 tote of polymer. Being able to use the full capacity of a tank can also cut down on the delivery frequency and overall delivery costs. There is also a manpower cost for sending operators out into the field to measure and report back on inventory levels. Lastly, don't forget about the safety aspect of not having people continuously climbing around tanks or going into hazardous areas to try to get a level measurement. And those costs can't always be measured on the bottom line. I think you can easily see how our new 80 GHz radars and controllers can be game-changing at a very attractive price point. We provide expert advice, training, and a service group that is unmatched in the industry. If you are in Northeast Ohio, I look forward to talking further with you about how we can solve your problems. If not, feel free to reach out to us and speak with the expert that covers your area. I appreciate your time and hope you walked away with some valuable insights. Thanks and have an awesome rest of your day.